Hello everyone. In this video we are going to discuss about the basic concepts of graph theory. Okay, so we'll start with the basic terminologies in the graph theory, and then we'll discuss about some theorems which are there, and then we'll solve some practice questions. So in beginning we understand what is the definition of a graph. So we can say a graph G is equal to V comma E. See, graph is always represented in the form of sets, okay, where V is a set of vertices and E is a set of edges. So when I am saying G is equal to V comma E, where V is set of vertices and E represents the set of edges, okay, and these vertices are also called as nodes. Now each edge has either one or two vertices associated with it. It's saying each edge has either one or two vertices associated with it, which is called as a end point of that vertex. For example, if I say this is the first vertex V1, this is the second vertex V2, and this is representing an edge E1. Okay, so this edge is associated with two vertices, which is V1 and V2, which are also called as the end point of E1. Okay, and an edge is set to connect its end points. Now this is how we represent a graph. Now for example, this is also representing a graph which is having three vertices. This is vertex V1, vertex V2, and vertex V3. This is edge E1, edge E2, and this is edge E3. So what are the end points of edge E3? That is V3 and V2. What are the edge points of edge E2? That is V1 and V2. Correct? Now there are different types of graphs that are there. Number one is simple graph, then we have multigraph, then we have pseudograph, then we have simple directed graph, then we have directed multigraph, and then we have mixed graph. Now what is the difference between these graphs? Now these graphs are differentiated in the form of number of edges, the kind of edge they have, and do they have multiple edge or not, and do they have loops or not. Okay, now what is a multiple edge? Multiple edge means between any two pair of vertices there are more than one edge present. Now for example, if I say this is a vertex V1, this is V2, and this is V3. Now this is representing a simple graph, correct? Why? Because all the edges which are there, they are undirected. That means there are no directions given. So this is a simple graph. Second, multiple edges are not allowed. Like for example, between V1 and V2 there are no multiple edges. And third one is loops are not allowed. Okay, now if I say, is this a multigraph? Is this a multigraph? Yes, it is also a multigraph. Why? Because it is undirected. Even though we do not have any multiple edges, but still multiple edges are allowed, and we do not have any loops. So this graph is representing a simple graph as well as it is also representing a multigraph. Third one is a pseudograph. Pseudograph means it should have undirected edges. It can have multiple edges, but loops, it can have multiple edges as well as it can also have loops. So this is also representing a pseudograph, correct? So this is just like we are giving more freedom in all these cases. That means any graph which is a simple graph, it is also a multigraph, it is also a pseudograph. Now if I say I have this kind of graph, that is, this is the vertex V1, this is vertex V2, this is vertex V3, but in this graph we have two edges between the vertex V2 and V1. So these edges, if I say we have two edges, now for example this is one edge E1 and this is representing the second edge E2. So because there are two edges, so now this is not a simple graph. It is not a simple graph. Why? Because there are multiple edges between the vertex V1 and V2. These two edges are connecting the same pair of vertices. Second, is it a multigraph? Yes, it is a multigraph. Why? Because there are multiple edges, correct? Is it a pseudograph? Yes, it is a pseudograph. In the same way, you can find out for the other points also. Now, if I say what is a pseudograph itself, then we can draw a graph like this. This is the vertex v1, this is vertex v2, this is vertex v3, and we have a self loop at vertex v2. Okay, what is a self loop? Loop is where with for an edge, if starting vertex and ending vertex both are same, now that is called as a loop. Now is it a simple graph? No. Why it is not a simple graph? Because because for example in between v1 and v2 there are multiple edges that are present. Why it is not a multigraph? Why? Because in multigraph loops are not allowed, but this graph is having loops. Is it a pseudograph? Correct, it is a pseudograph. Now we'll see just some examples of all these 6 graphs in the next slide. Just have a look at this. Now this is representing a simple graph. Okay, as I told you, what is the definition of a simple graph? A simple graph is a graph which is not having any multiple edges, and it is also not having any kinds of loops. Okay, so therefore it is representing a simple graph. Now if I say this graph, now this graph is not a simple graph, but it is a multigraph. Why? Because in this case in a multigraph you say there are multiple edges allowed but loops are not allowed. Okay, so this is clearly we are saying it is a multigraph because multiple edges are allowed but loops are not allowed. Now if you see this example is representing a pseudograph. Pseudograph means the graph is undirected, multiple edges are allowed as well as loops are allowed. So because between every city here the loops are also allowed and multiple edges are also allowed, so this is a pseudograph. Then we have this graph which is representing the simple directed graph. That means multiple edges are not allowed, loops are not allowed, but directions are allowed. So you can see between every pair of cities here there are given some directions. Like for example, between San Francisco and Denver we have a direction, and that means we have an edge between San Francisco to Denver, but we do not have any edge between Denver to San Francisco. Then we have Los Angeles and so on, correct? Because their directions are given for this graph. Now this graph was simply representing a simple directed graph. In the same way we can have directed multigraph and we can have mixed graphs. Now look at the definitions here. What is a directed graph? A directed graph or digraph is represented by v, e, that is set of vertices, and e is a set of edges, which is consisting of a non-empty set of vertices. See, whenever we are discussing about graph definition, it is always non-empty set of vertices, because without having any vertex a graph cannot exist. And a set of directed edges, you see, without having an edge a graph can exist. For example, if I say we have 3 vertex v1, v2 and v3. Now even if there is no edge between these 3 vertices, but still it is called as a graph. Okay, so for a graph having a vertex is important, or you can say it is mandatory or it is necessary, but having an edge, it is not at all necessary. Now each directed edge is associated with an ordered pair of vertices, and the directed edge associated with the ordered pair is said to start from u to endpoint of v. So this is just a definition of directed graph. What does it mean? It is saying that if we have 3 vertices v1, there is a vertex v2 and there is a vertex v3. Now a directed graph v, e consists of non-empty set of vertices. Yes, it is a non-empty set of vertices and set of directed edges. Like for example, between v1 to v2 there can be an edge. There can be an edge between v1 to v2, right? In the same way we can have an edge between v2 to v3. We can have an edge between v1 to v3. Okay, so each directed edge is associated with the ordered pair of vertices. Ordered pair of vertices means between v1 to v2 we can have an edge, but between v2 to v1 we do not have an edge. Okay, so v1, v2, this ordered pair is not at all equivalent to v2, v1. So these 2 ordered pairs are not at all equal. So that is why we say when we represent the set of edges, then it should be an ordered pair. Now what does it mean when I'm saying ordered pair? Assuming that this is one graph, this is vertex v1, this is vertex v2 and this is vertex v3. Now this graph is a completely undirected graph. This is a undirected graph, right? Now if I'm showing what are the vertices we have, or what are the edges we have, Then we can have three kinds of representations. Number one, we can have adjacency list representation. Second one, we can have adjacency matrix representation. And third one is we can have set representation. Now we have already seen the adjacency list and adjacency matrix representation in data structures also, and in the coming videos we are also going to discuss about the adjacency list as well as the adjacency matrix, but here we are using the set representation. Now when we have undirected graph, now here we have in this set we represent unordered pair of vertices. Unordered, that means we can have v1 comma v2, there is an edge. Between v2 comma v3 there is an edge. Between v1 comma v3 there can be an edge. Okay, it represents that v1 comma v2 is equivalent to saying v2 comma v1. This is in case of undirected graph. That means the order does not matter. v1 comes first with v2, that does not matter. Okay, but when we have a directed graph means we can have vertex v1, v2, v3. Now in these three vertices there is an edge between v1 to v2, there is an edge between v2 to v3, and there is an edge between v3 to v1. Now how we are going to write the pair of vertices, pair of edges? We can have v1 comma v2, we can have v2 comma v3, we can have v3 comma v1, but it does not mean that v1 comma v2 is equivalent to v2 comma v1, because when I'm saying v2 comma v1, that means there's a directed edge between v2 to v1. So in case of undirected graph we use unordered pair of vertices to represent an edge, but in case of directed graph we always use ordered pair of vertices to represent an edge. Okay, so each directed graph is associated with ordered pair of vertices, and a directed edge associated with the ordered pair is said to start from u and end at v. For example, if I say u comma v, that means the edge is from u to v. Okay, now here you can see all the edges that are represented in this graph, they are the directed edges. Okay, then that graph with where we were having directed edges, let me show it to you. Now this graph where we were having all the directed edges, we do not have any loop in this graph. So this graph is representing a directed multigraph. Okay, there are multiple edges are allowed as well as loops are allowed, but it is not representing a simple graph. Why it is not representing a simple graph? Because if you see that between San Francisco and Denver there are two paths are possible, there are two edges with the same directions are possible, therefore it is representing a directed multigraph. Correct? Now look at this this definition. It is saying two vertices u and v in an undirected graph G is called adjacent if in G if u and v are endpoints of an edge of G, edge E of G, such that E is called incident with the vertex u and v, and E is said to connect u and v. That means first of all they are discussing about the undirected graphs where no directions are given. Now if there is a vertex u and there is a vertex v, now these two vertices are called as adjacent when and only when there is an edge which is existing between u and v, which is having one endpoint as u and second endpoint as v. Okay, so such kind of vertices are called as adjacent vertices. Now look at this definition. A degree of a vertex in an undirected graph is the number of edges incident with it, except that a loop at a vertex contribute twice to the degree of vertex. The degree of vertex v is denoted by degree of v. Okay, what does it mean? It means, let us suppose we have these two different kinds of graph. This is an undirected graph. This is v1 vertex v2, this is vertex v3. Now this is a second graph which is a directed graph. Directions are given. this is vertex v1, this is vertex v2, and here it is vertex v3, and this is representing an edge. Okay, and we have one more graph here. This is vertex v1, this is vertex v2, there's a self loop, and this is vertex v3. Now when I'm saying a degree of a vertex in an undirected graph is the number of edges incident with it. Now this is discussing about the undirected graph, and they're saying the number of edges incident with it. Okay, now for example, if I say what is the degree of vertex v1, degree of vertex v1 is what are the number of edges incident with the vertex v1, which are 2. Now what is the degree of vertex v2? Degree of vertex v2, that is equivalent to 2. What is the degree of vertex v3? That is also equivalent to 2. This is undirected graph. Now second graph, this graph g2, it is an directed graph. Now if I say what is the degree of vertex v1, now here the degree of vertex v1 is 0 because there is no incident vertex, right? Now for a directed graph, we'll be discussing about what is the in degree and what is the out degree. Now here we are just discussing about the out degree. Now what is the degree of vertex v2? Degree of vertex v2 is 1 because there's one incident edge here. And what is the degree of vertex v3? That is equivalent to 2 in the directed graph. Now the third graph, which is represented by this graph g3. Now this is an undirected graph. What is the degree of vertex v1? Degree of vertex v1 is 2 because there are 2 edges incident. What is the degree of vertex v2? Vertex v2 degree is 1, 2, 3 and 4. So degree of vertex v2 is 4. In the same way, what is the degree of vertex v3? That is represented by 2. So this is called as a degree of a vertex. Now look at this one. This question. What are the degrees and what are the neighborhoods of the vertices in the graph G and V? Now you say what is the degree of A? Degree of A is 2 because there are 2 edges. What is the degree of B? Degree of B is 1, 2, 3 and 4. There are 4 edges. What is the degree of F? Degree of F is 1, 2, 3, 4. So there are 4 edges. What is the degree of vertex E? That is 3. Degree of vertex C, that is 3, and degree of vertex D, that is equivalent to 1. So this is the degree of each and every vertex here. Now look at this one here. What is the degree of vertex A? Degree of vertex A, because there are multiple edges between 2 pairs of vertices. So here 1, 2, 3 and 4. Now in this graph, because it is having multiple edges between the same pair of vertices, like for example between A and E, there are multiple edges. Now here the degree of vertex A will increase and degree of vertex A now will become 4. Okay, but in the original case the degree of vertex A was only 2. Now what is the degree of vertex E? How many edges are there? 1, 2, 3, 4, 5 and 6. So degree of vertex E is 6. What is the degree of vertex B? Vertex B is 1, 2, 3, 4, 5 and 6. There are 6 degree. What is the degree of vertex D? Degree of vertex D is 1, 2, 3, 4, 5. And what is the degree of vertex C? That is equivalent to 1 only. So this is representing a graph and we found out what is the degree of each and every vertex. Now when I said neighborhood of every vertex, neighborhood, for example here for this particular graph, what is the neighborhood vertices of any particular vertex? For example, if I say what is the neighborhood of vertex A, neighborhood are the vertices which are adjacent to A. B is adjacent to A, E is adjacent to A and D is adjacent to A. So neighborhood of vertex A is B, D and E. In the same way, what is the neighborhood of vertex B? So see, even if the degree of vertex B is 6, but the neighborhood can be less because vertex B is having self loop. But still, what is the neighborhoods of vertex B? That is A, B, C, D and E. So in neighborhood of B there are 5 vertices, but the degree is 6. That means if the degree is more than the neighborhoods, so they may contain some kind of self loop, correct? In the same way, if I say what is the neighborhood of D, so neighborhood of D is A, B, E. So in D we have A, B, E, correct? But still there's 3 vertices in the neighborhood, but the degree of D is 5. So still, because there's a degree of D is 5 and neighborhood of E it is having 3, so either D can be having any kind of self loop or it may be having any kind of multiple edges, correct? So this is an example of degree and the neighborhood of the vertices. Now look at this one. The next is the handshaking theorem, or you can say the handshaking lemma. So let's do one thing. In the next video we'll be discussing about the handshaking theorem. So in this video we just had a discussion about the basic terminologies of graph theory. Now we'll be starting with the handshaking lemma, or you can say the handshaking theorem, from the next video onwards.